Welcome to the official podcast series by POTENZA, where innovation meets insight. In this series, we dive deep into the world of SAP, explore the power of robotic process automation, and unlock the true potential of data analytics. Whether you're a tech enthusiast, a business leader, or just curious about the digital transformation shaping our world, you're in the right place. Tune in, stay curious, and let's explore the future of enterprise technology together. Don't forget to subscribe and follow us on YouTube for more powerful insights. Now, let's get into today's episode.
The moment you start talking about paper, about digital files, the conversation, it often gets bogged down in IT procurement.
It really does.
But what we're diving into today, document classification automation, this isn't just a technical curiosity. It is rapidly becoming a strategic imperative for any executive dealing with high volume.
And the volume is just staggering.
Think about the scale. A mid-sized financial institution, according to our sources, might process 50,000 inbound documents every single month.
50,000. And that volume is exactly why this whole process, just figuring out what you're looking at and where it needs to go, becomes a massive business bottleneck.
So what are the critical problems there?
Well, when you rely on human review, you hit three. First, your processing speed just can't scale. Adding more staff means linear, constant cost growth.
Right.
Second, human error rates are significant. They consistently run between, say, 3 and 5%, which creates painful rework, regulatory risk.
And third,
You just lack the real-time responsiveness that, customers and modern business systems demand.
so our mission today is to really understand that strategic move. How do organizations get from those old, rigid methods to the new, flexible AI-powered systems?
To set the table, let's define it. Document Classification Automation, or DCA, it's essentially the engine that takes those messy streams of unstructured documents.
Things like emails, attachments, scans.
Exactly. And it systematically categorizes them into predefined classes, all without needing human hands. It transforms chaos into organized, actionable data streams.
Okay, so let's start with the old guard. When this field first emerged, the methods were purely reactive. They were built to digitize paper. We're talking about traditional classification.
Right, and that relied heavily on what we call rule-based classification.
What does that actually look like in practice?
It's all based on explicit logic. You, the operator, have to manually write the precise conditions. A classic example is, if the document contains the text invoice in the header A&D, it includes a line item labeled amount due, then classify it as an invoice.
And that works well in a predictable world.
It worked brilliantly. For highly standardized documents, say mortgage forms from a single government agency, you could easily hit 90% accuracy, maybe higher.
But the real world is rarely that stable, is it? Documents are constantly changing. So what happens when these template-driven systems meet even a little bit of variation? What's the fatal flaw?
The flaw is its inherent brittleness and the high cost of maintenance that comes with it.
Or brittleness.
Yeah. Template-driven systems try to match the physical layout of the document. So if a vendor just changes their logo placement or moves a field by a single column,
The rule breaks.
the whole thing breaks. They struggle severely with semi-structured and unstructured documents, things like customer correspondence or contracts, where the layout is never the same twice.
And the constraint here is just one of scale.
Absolutely. The maintenance becomes an exponentially complex nightmare. I mean, an organization processing 50 different document types might be managing hundreds, even thousands of specific hard-coded rules.
And every time a form updates, you have to manually go in and revise that rule set.
Exactly. You're creating this tremendous technical debt and constant operational overhead.
And that pain point, that spiraling cost of maintenance, is really what drives the AI revolution we're seeing now.
It's the primary driver.
The core difference with AI-powered DCA is, well, it's simple. It doesn't follow explicit rules you wrote. It learns patterns from examples.
And that ability to learn is what allows the system to generalize, to adapt to variations it has never specifically seen before. That gives it real resilience.
So that's a strategic breakthrough. And the technology that makes it happen is natural language processing, or NLP.
Right. Traditional systems just look for keywords, a very surface-level approach. NLP allows for semantic understanding.
So break down semantic understanding for a strategic listener. Someone who doesn't need to code it, but really needs to get the functional impact.
Of course. Think of it like this. A rule-based system sees the words invoice and dispute and says, okay, this is about an invoice.
Simple keyword matching.
Simple keyword matching. A system with semantic understanding is more like a lawyer reading the context. It sees the sentence structure, the verbs, and it realizes this is a request for resolution, not just a reference. It can distinguish an invoice dispute from an invoice approval.
And that's a nuance that completely changes your workflow, your risk profile.
Instantly. It changes who needs to see it and how quickly.
So how does the machine actually achieve that? I know we get into jargon here, like named entity recognition.
We can keep it high level. Basically, the NLP system acts like a methodical detective. First, it breaks the sentence down into individual pieces. That's called tokenization.
Okay.
But more importantly, it uses named entity recognition to instantly identify the players in the text. It knows Acme Corp is a company, March 1st is a date, and 123 Main Street is an address, no matter where they appear.
So it's building a richer picture.
A much richer picture. By mapping those players and the relationships between them, the system builds the features it needs for an accurate contextual classification.
And once you have those rich features, then you apply the machine learning models. I know we have two main flavors here, right? Traditional ML and then the heavy artillery deep learning.
Right. Traditional machine learning, it uses supervised learning. It's trained on labeled documents, usually hundreds, maybe a couple thousand per class. And these models, like support vector machines, handle variation quite gracefully.
So if your training data includes invoices from 15 different vendors,
the model learns the underlying criteria for all of them, not just one rigid template.
and then you step up to deep learning. This is where we hear about neural networks and transformers.
Deep learning is the cutting edge, yeah. It uses these neural networks to learn hierarchical features automatically. You don't have to tell it what's important. It finds the most predictive elements all by itself.
Which sounds amazing for really unstructured stuff like emails or complex legal contracts.
It is. It's incredibly powerful.
But there's a big strategic trade-off here. Is deep learning always worth the investment for this kind of work?
Absolutely not. And the dependency is data and cost. Deep learning needs significantly more training data. We're talking thousands, maybe tens of thousands of examples per category.
And more computing power.
Much more. For training and for running it. Look, if 80% of your documents are standardized invoices, a good ML model might get you to 95% accuracy. Deep learning might push you to 97%, but that extra 2% could require 5 times the data and engineering effort.
So you have to ask if that marginal gain is worth the monumental cost.
Exactly. It's a tool you choose for the complexity of the problem, not a universal upgrade.
That makes sense. Okay, let's put them head to head. Let's talk numbers. For organizations evaluating this, what are the hard metrics in this showdown?
Let's start with accuracy and stability. Traditional systems, like we said, they peak around 85 to 92%.
But only when the documents stick to the script.
Only then. AI systems, once they're trained correctly, consistently hit 93 to 98% accuracy across document types, including the semi-structured ones.
And the stability of that accuracy, that's where you save money, I imagine.
Precisely. Let's say one of your major partners changes their invoice format. A 5% change in the layout. A traditional system's accuracy might plummet by 15, maybe 20 percentage points overnight.
Which means a sudden, massive pile of manual review.
A costly mess. The AI system, because it generalizes, might only degrade by 2 or 3 percentage points. It is just inherently more resilient to real-world chaos.
And that resilience translates directly into scalability. How does AI handle rapid volume growth compared to just maintaining thousands of rules?
It's a totally different curve. Traditional systems require linear or sometimes even superlinear growth and complexity. You double your document types, your rules might quadruple.
Right.
AI systems scale sublinearly. The model structure is fixed, so doubling your document volume might only increase your infrastructure and processing costs by, say, 30 to 40%. The operational model becomes much more predictable.
Okay, let's talk dollars and cents, the financial trade-off. AI generally requires a higher upfront investment, right?
It does. You've got higher initial costs because data preparation, labeling, model development, these are complex, specialized tasks.
But the long-term costs are where the story changes.
Massively. Traditional systems suffer from vastly higher long-term maintenance costs. We often see them run 20 to 30% of the initial setup cost annually just for rule maintenance.
Compared to AI.
AI systems, by contrast, typically sit in the 10 to 15% annual maintenance range.
So the total cost of ownership, the TCO, that's the metric that really matters here.
It's the whole ballgame. And that TCO crossover point, where AI becomes definitively cheaper, it usually happens pretty quickly. Around 18 to 24 months for any medium to high complexity scenario.
And that crossover, That's the key insight for any executive planning their budget.
That's it. That's the strategic inflection point.
So once you pass that point, the benefit shifts. It's not just about saving money anymore. It's about driving a real strategic advantage. Let's look at some concrete ROI examples.
Okay.
We're talking accelerated speed, reduced errors.
The acceleration is transformative. We see automation speeding up the overall process by anywhere from 10 to 50 times what a manual effort looks like.
Wow.
Take that finance example. A firm processing 10,000 transactions a month reduced the time for just initial classification and routing from 40 hours down to just 1.5 hours.
40 hours to 1.5.
Yeah.
That immediately frees up staff to focus on exceptions, which is where you actually want human brains working.
That's the high-value work. And then there's the error rate. You're moving from that painful 3 to 5% human error down to maybe 0.5% to 2% with automation. That immediately cuts rework costs and customer friction.
There's a great anecdote from logistics I saw. A freight company dealing with documents in 23 different languages.
That one's fantastic because it highlights the power of NLP. The AI system successfully classifies the document type. Is it a bill of lading, a customs form, a hazmat manifest, independent of the language?
Because it's reading the function of the document, not just the text.
Exactly. And for them, it reduced manual classification effort by 70%, and accuracy jumped from about 82% to 94%.
Incredible. And what about a highly regulated industry like healthcare?
In healthcare, it's vital. AI systems can handle the sheer variety of claim formats from different providers. This reduced the classification errors that cause claim denials by a staggering 62% in one case we looked at.
That is a massive financial win and a huge reduction in patient friction.
A huge one. And in the legal world where semantics are everything, the AI has to understand intent. It has to know the difference between, say, a master service agreement and a statement of work.
Which said framework terms versus project deliverables?
Right. And that distinction is critical because they route to different legal teams, they carry different risk profiles. The AI uses its deep NLP capabilities to make that call, achieving 94 to 96% accuracy. The right document lands on the right lawyer's desk the first time.
Okay, so that brings us to implementation reality. Because AI is not a magic wand you just wave over your documents. It comes with some significant constraints leaders need to understand.
The first and the most obvious one is data dependency. Who pays for the training data? For reliable machine learning, you need, say, 500 to 2,000 high-quality labeled examples per category.
And for deep learning, it's even more.
It jumps to 2,000 to 10,000. Many organizations just don't have enough historical, clean labeled examples, especially for those really complex or rare document types.
And the second major hurdle seems to be managing expectations.
Exactly. Business stakeholders often come into this process expecting 100% automation. You have to be realistic. You're aiming for 93 to 98% because, let's be honest, human classification isn't 100% accurate either.
That's a great point.
And you have to let the economics guide you. If getting to 95% takes 1,000 training examples, but getting to 98% takes 5,000, you have to justify the cost of labeling those extra 4,000 documents.
So given all that, when does the traditional, simpler approach still make strategic sense?
Traditional systems are still perfectly viable when you have low volume, fewer than 1,000 documents a month, and your formats are highly stable, maybe dictated by a regulator.
Right, simple and auditable.
Exactly, where the explainability of a simple rule is more important than a few extra points of accuracy.
And conversely, what's the sweet spot for maximum AI value?
AI delivers the most value in high-volume environments, 5,000 a month and up, or places with high diversity, rapid change, or where you need straight-through processing. If you absolutely cannot afford manual intervention, AI is the only path forward.
Looking ahead, it seems like classification is just the starting point. The technology is already shifting beyond simple categorization.
Oh, absolutely. The move is toward real-time intelligent document understanding. It's not just classifying invoice. It's classifying invoice, extracting the vendor, amount, date, line items, and instantly populating those details into your accounting system.
All in milliseconds. No more batch processing delays.
None. And the ultimate goal is holistic automation. We're talking end-to-end process automation where this intelligent document processing combines with robotic process automation.
So a system could receive an invoice, classify it, extract the data, validate it, do a three-way match with the purchase order, and then execute the payment.
All fully automated. And that holistic view really provides the final synthesis. DCA is the foundational step for this broader intelligent automation across the whole enterprise.
So the strategic imperative for you, the leader, isn't if to automate.
No, it's how to implement automation that can scale with your growth, manage real-world complexity, and align with your existing capabilities.
That analysis really connects the technical dots to the strategic risk. So let's leave you with a final provocative thought for today.
Okay.
Today's AI systems require periodic manual retraining, but the future is autonomous learning. We're talking about systems that monitor their own confidence levels.
And can flag when they're uncertain.
Exactly. They automatically identify those uncertain classifications, request human feedback only on those specific cases, and then use that one correction to update their own models, all in real time.
Which means the system learns continuously from production experience. It drastically reduces that long-term maintenance burden.
So if today's AI systems are already starting to learn from their own corrections and automatically maintain their accuracy, what whole processes could you transform if you eliminate the need for those costly manual retraining updates entirely?
A great question to ponder.
Think about that as you consider your next steps in automation. We'll catch you next time.
That's a wrap for today's episode of the POTENZA podcast series, where we decode SAP, automate with RPA, and analyze with precision. We hope you found today's conversation insightful and inspiring. If you enjoyed the episode, make sure to like, share, and subscribe to our YouTube channel, and stay tuned for more deep dives into the technologies transforming tomorrow's enterprise. Got questions or ideas for a future episode? Drop them in the comments, we'd love to hear from you. Until next time. Thank you.